Hello friends, as in our previous video we have discussed about the creation of the single linked list, and in this video we are going to discuss about the insertion operation in a single linked list. So insertion of a node. One of the most primary operation that can be done in a single linked list is the insertion of the node. Memory is to be allocated for the new node or in a similar way that is done while creating a list. Before reading the data, the new node will contain empty data field and the empty next field. The data field of the new node is then stored with the information which was written from the users, and the next field of the date of the new node is assigned to null. And after that, the new node can be inserted at three different places. They are inserting a node at beginning, inserting a node at end, or we can also insert a node at an intermediate position. So let us start with the insertion of node at beginning. So to insert a node at beginning, we have to initially we have let's suppose we have a simply this type of a linked list, and after that what we need to do, we need to add the list at the beginning. It means before the node having the address 100. So how can we do that? We can do that by breaking the link of the start and the first node which contains the address of 100, and assigning the address of the new node which we are creating, and we want to add that new node at the beginning of the linked list. We have to assign that address of that node in the start pointer, and after that we have also put have to put the address of the first node which contain initially first node which have the address, suppose say 100, and we have to provide that address into the new node next field, so that the first node the new node which we want to initialize in the beginning of the node can be initialized as the first node of the linked list, and can link the another node, the left one nodes, with it. So how can we do that? So for doing that, the simple operation, we need to follow some of the steps to insert a new node at the beginning of the list. So first we are going to get a new node using a get node function by implementing a new node is equal to get node, and after that we have get return a new node into a new node variable or a pointer. And after that we will check the linked list is empty or not. If the linked list is empty, so it means mm, the start pointer has an initialized with null, having a value null. And then if the list is empty, then we are going to initialize the start pointer with the next new node means which means an we are providing the address of the new node into the start pointer. And if the address of if the linked list is not empty, then we have to provide the new nodes next. The address of the we have to provide the address of the first node of the previous linked list into the new nodes next field. So for that we have to uh, take the address which was stored in the start pointer. We have to initialize a new nodes next field with that address which was contained in the start. And after that we have to initialize the start pointer with a new node address, and we are using insert at beginning function for initializing a node at the beginning. So in such a way, we can insert a new node at the beginning. So now we are going to discuss about the insertion of node at the end. So to insert a node at an end, let's suppose we have simply a linked list, this type of a linked list, and we need to add the new node which we have created at the last end of the single linked list. So for that, we have to assign the next field of the last node with the new node address. So it was the one of the simplest insertion of a single link in a single linked list. So for doing that, this insertion at an insertion of a node at the end of the linked list, we have to follow some of the journal steps. They are, as we have discussed, some of the steps are similar as in the insertion of the node at beginning. That was the we are getting a new node using the get node function, and after that we have to check the link list, that is the link list is empty or not. If the link list is empty, then we have to initialize the start pointer with a new node. Else, if this linked list is not empty, then we have to take a pointer temp which stores the same as the address of the start, and we have to with that temp we are going to that we are going to traversing the throughout the linked list, and we have to reach at the last node of the linked list. And after that, if we have after when we have reached the last node of the linked list, then we have to implement the next field of that last node with a new node's address. So in such a way we can such a simple way we can insert a new node at the last of the linked list. So now, after inserting a new node at the at the end of the linked list, now we are going to just discuss about the how to insert a new node at an intermediate position. So to insert a new node at an intermediate position, we simply yeah, for inserting a simply node inserting a node at an intermediate position, just let's suppose it will be our linked list, and we need to insert a new node at the position third position. So what we need to do, simply we need to break the link of the second node and the third node, and we have to place a new node in between that, and want and have to link that node with the second one and the third one. So in such a way we can insert. So how can we, what are the steps to insert the new node at an intermediate position? So they are, so initially we have to use the new node get node function for getting the new node, and after that we have to ensure that the specified position is in between the first node and the last node, which means that as we need to insert a new node at an intermediate position if it might be the position which is does not existing between the first node and the last node. We cannot insert the node at that specific position because the position is invalid. So we are going to check that, ensure that the specified position is between the first node or the last node. If no, if we found the specified position is not in the between the first node and the last node, then we will just print a specified position is invalid. This can be done by using the count node function. In the count node function, which is just simply you use to count the number of the nodes of the linked list. So after that, we have to store the starting address. After if the specified position is in between the first node and the last node, so after that we have to store the starting address. Starting address, which is a start pointer in a temp and previous and a pre and in a pre pointer. We have to just store the start pointer. The start address of the start address starting address means the start pointer in the pointer and the temp pointer, and then we are going to traverse the mm, temp pointer up to the specified position and follow and specified position followed by the pre pointer. After reaching the specified position, following we are going to implement some of these steps. They are we are going to implement initialize our address of next field of the next field of the pre pointer with the new node, and a new node next field with the temp as the pre 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 pointer points towards the this one node, and the temp node is pointing toward this node. So as we have said that we are going to implement the next field of the pre pointer. So the pre pointer is pointing toward this node, and the next node of this pointer is this, and we are initializing this with our new node. So our new node address will be initialized in the this pre pointed node, and after that we are going to initialize our next new node next field with the temp temp and the temp is pointing toward the following node, this one node, and the node this one node address will be initialized with in the next field of the new node. And in such a way we have done with the insertion of inserting a node at an intermediate position. And after completing all the steps of insertion, creation and deletion and traversing, we are going to create a complete program by using these same algorithms. So this much for this video, and in the next video we are going to learn about the deletion operation.